Greetings and welcome. Subscribe the channel Thermal Engineering for video sessions. In this session you will be able to explain properties of fluid, viscosity, to know what is viscosity. Let us have a look. Here in this video clip we see water flows fastly. This is the another fluid, that is honey. We see here that it flows slowly. Here in this experimental clip we see these are the three liquids inside this tube, and when the sphere is released in these three liquids, here we find the sphere in the biodiesel column is moving fastly, while the ball in glycerin column is flowing very slowly. So why it is happening? So it is happening due to the resistance offered by the fluid which is inside the tube to its flow. So from this we can say that viscosity, this is what a property of fluid. It is internal resistance offered by the fluid to its flow. Now this property is due to strong cohesive forces between the molecules of the fluid. Here we see this is a liquid which is flowing over the plate. So here at the surface, solid surface, where the molecules of liquid are in contact with solid surface, there we see velocity of this fluid layer is 0, u is equal to 0. Now this condition is called as no slip condition. Now this is what resistance or viscous nature of the fluid. Now as distance from this plate is in upward direction increasing, the velocity is increasing. So at the top here the fluid is flowing with velocity equal to capital V, that is called as free stream velocity. So here is a Newton's law of viscosity, which is mathematical treatment of viscosity. So as we discuss, here we will take, this is a flat surface over which fluid is flowing. So here are two layers. These two layers of a fluid which are at a distance of dy, these are moving with velocity u and u plus du. U is a velocity of lower layer and u plus du is the velocity of upper layer. Now when these fluids are flowing in the layers, these are subjected to shear stress between them. By this shear stress, here the lower fluid will apply force on the upper layer and upper layer will apply force on the lower layer. This shear stress is proportional to the velocity gradient, that is du upon dy, means change in velocity to change in distance, vertical distance. So here this is a equation of proportionality. Tau is directly proportional to the du upon dy. Mathematically we can write this equation, tau is equal to mu into du upon dy. This is called as Newton's law of viscosity, where this mu is coefficient of viscosity. It is called as dynamic or absolute viscosity. Now here, as far as various forms of Newton's law of viscosity concerned, in mathematics two forms are used. One is a differential form, that is Newton's law of viscosity, and second one is integral form, So in this integral form we can write this tau means shear stress, that is ratio of force to area of moving surface which is contact with fluid, and shear force that is applied by the one layer over another layer. So F upon A means shear stress, force unit is Newton, area unit is meter square. So Newton per meter square will be the unit of shear stress. Right side here mu, that is constant, already we discussed. It is called as coefficient of viscosity. Now its unit will be what? If you write this mu, that will be equal to tau upon du upon dy. So by arranging the units and simplifying, we find the unit Newton second per meter square. It is also indicated with another unit, that is Pascal second, because Newton per meter square is a Pascal, unit of pressure, or in SI unit in a MKS system, kg per meter second. Velocity gradient, that is du upon dy, it is also called as rate of shear strain or rate of deformation, and its unit is per second. Capital U, in integral form, this change in velocity means final velocity minus initial velocity. So final velocity is taken with letter capital U. Initial velocity is 0, so U minus 0, that's why capital U. And for the distance, it is use Y, capital Y. In this case, this capital U is linear velocity of moving surface, that is equal to velocity of layer adhere to moving surface, and this is given in meter per second. There are mainly two types of viscosity: dynamic viscosity and kinematic viscosity. Dynamic viscosity already we have discussed, that is mu. According to Newton's law of viscosity, mu we write equal to tau upon du upon dy. Now here how the unit come Pascal second, that is elaborated. So here first of all this shear stress Newton per meter square is written. Du upon dy, that is a velocity gradient. So change in velocity meter per second divided by this meter. So 1 divided by this will come here, that's why it becomes m means meter divided by meter per second. So in this case cancellation of meter will take place here. Cancellation, after the cancellation what remains? Newton remains, meter square remains, and this second comes here at the numerator. So Newton second per meter square. Here we can have this Newton means force, that is mg, mass into acceleration due to gravity. So by that we can find here kg, kilogram, at the numerator after the cancellation of the term. So kg per meter second, and Newton per meter square means pressure unit Pascal. So here Pascal second. So we have different units of dynamic viscosity over here. From above equation, viscosity may also be defined as the shear stress required to produce unit rate of deformation, that is called as shear strain. SI unit of dynamic viscosity is Pascal second. Now here for the calculation purpose smaller unit is also used, that is called as poise, and the relation between this is 1 Newton second per meter square is equal to 10 poise. Second type of viscosity is kinematic viscosity. It is indicated by letter nu. In many problems involving viscosity, frequently there appears a term dynamic viscosity mu divided by mass density. Means its relation is what? Mu upon rho. So this is what kinematic viscosity. So here by putting the units of mu and rho unit, that is kg per meter cube, here arrangement of the term and cancellation of the terms, we find here meter square per second. So meter square per second is a SI unit of kinematic viscosity. So as it involves only the magnitude of length and time, it is also called as kinematic viscosity. Now this meter square per second, this unit, we use another unit for the calculation purpose, that is stoke, and 1 stoke is equal to 1 centimeter square per second, and 1 meter square per second is equal to 10 raised to 4 stokes. So at the end of this session, you can explain what is viscosity, Newton's law of viscosity, and types of viscosity. Subscribe the channel for further video sessions of fluid mechanics. Thank you.